Morning, guys. Had some technology issues, so we're getting going. So we're jumping all the way to section 11.1. It's part one. We're going to break chapter 11 up into two parts. First one, we're talking about trigonometric ratios. Trying some different writing here. We'll see how well it works in the next couple of days. So here we go. So there's trigonometric ratios, and I'll show you what it's based off of. It's based off of our right triangle. So we're back to kind of the idea that we have a right triangle. I know my drawing is horrible. I'm working on that tech issue. So we're basing it on the right triangle here, okay? And I'll explain that. So when you're working with your trig ratios, these are the ones you have to worry about here. So we have where's it at? There it is. We have sine, sine. It's not sin, it's sine. It is sine of theta, and I'll explain what theta is here in a minute. It's your opposite side over your hypotenuse side. And then its inverse is cosecant. It's abbreviated CSC. Theta, again, I'll explain theta here in a minute. It's the angle, actually. Hypotenuse over opposite. And then we have cosine. Cosine is abbreviated COS, adjacent over hypotenuse. Secant is its inverse, and it is secant SEC, and it's hypotenuse over adjacent. If you notice, it's adjacent over hypotenuse, and we just flip it over to become hypotenuse over adjacent. And then we have tangent. Tangent is equal to opposite over adjacent, and its partner, a reciprocal partner, or its inverse is cotangent, and it's abbreviated COT. And then you get adjacent over opposite, which is just these two flipped over. All right, so where do you think the names come from of the sides? Oh, sorry, where do you think the names of the sides come from? Well, the idea is this: that we have an angle, and we're going to call it theta. That's what it's called, theta here, and it means the reference angle. So what they mean by the reference angle is it's the angle from where we're looking. So this kind of looks like an eye. So to help some people understand, I usually like draw like a little eye in there, and this eye right here. This eye of theta is always looking across to the opposite side. So theta and the opposite are always across from each other. So this angle, A, is always theta. Shouldn't say always theta. It is theta in this one. B can be theta. Any one of these angles can be theta. They have to tell you that. So this reference angle is A. And so since theta is A, then what we're looking at is the fact that this is opposite. The side right next to or adjacent to angle A is the adjacent side, and always across from the hypotenuse is the right angle. So we have them here. Remember, we have our uppercase angle, and our uppercase angle is always across from our lowercase side. So if we kind of keep moving with that idea, knowing that we're always looking from the reference angle, if we take the first one here, I'd like you guys to label the sides. So we've got it here, and we're saying that theta is angle B. So theta is angle B. Now I want you guys to label the sides with their names: opposite, adjacent, and hypotenuse. And that's what you'll be doing on Edpuzzle right now, and then we'll move on. Okay, so here's an example. If sine of B, angle B, is equal to 5 over 8, find the exact values of the 5 remaining trig functions. Well, there's 6 of them, if you remember from the beginning. So if there's 6 of them, we're given one of them, and then we got to find the exact values. All right, so let's tackle that real quick. So there is a system that we're going to be using quite a bit, and it's called GNA. I'll write the acronym up here. GNA W. Oops, that's supposed to be a W. W. Yeah, whatever. Pretty close. Writing with my mouse, guys. Sorry about that. So here's the idea. we know that sine, oops, wrong side. So this is going to be words, and this is words. Sorry, I put given there. I have a habit of that, but that's okay because in words we are given some information. So this is words. So here it is: graph, numerical, algebra, words. So what I did is I said, okay, I was given the sine of b is 5/8, 5/8. So that tells me that I have opposite over hypotenuse, which means that the opposite side is equal to 5 and the hypotenuse is equal to 8. So if I go up here and label my triangle, angle B is where my eye is. So I'm looking across to the opposite side, and I know from the equation that the opposite side is 5. So B is equal to 5. And then I also know my hypotenuse is 8, and it's always across from C, so I know that C is equal to 8. So if I know those pieces, let me slide down just a little farther. If I know those pieces, then all I have to do is take Pythagorean's theorem, because it is a right triangle, and I use Pythagorean's theorem. I know what C is, it's 8. I know what B is, it's 5. So if I square those two, well, you can square them, you don't have to square them. I did a little bit of math here for you guys. So I subtracted 5 squared and subtracted 5 squared from both sides. And so that's where that came from. So if I subtract from both sides, that's going to disappear. Gives me this. And then I know that 8 squared is 64. 5 squared is 25. Well, I get 39. And if I get 39, then I end up with a squared equals 39. A squared equals 39. That means the square root is equal to the square root of a squared, a is equal to the square root of 39. So that's how I kind of come up with my values here. Now I know that I got to go back up here. I know that a is equal to the square root of 39. And then from there, I'm just plugging it in. I know that sine is opposite over hypotenuse. So then cosecant must be its inverse. So I flip them and become 8/5. I know that cosine is adjacent from our previous, which is square root of 39, over the hypotenuse, which is 8. That means my secant is 8 over the square root of 39. My tangent is opposite over adjacent. My opposite is 5. My adjacent is square root of 39. So that's where those come from. And then my inverse, which is cotangent, we flip it, it becomes the square root of 39/5. So that's kind of how you solve them. I want to bring your attention to this one right here, and I'm going to write it down here. So this is a little side note. It actually doesn't go with, oops, hold on a sec here. Got to go a little farther. A little side note, bringing back some old math. So we know that it is it was secant. Oops, is equal to 8 over the square root of 39, right? Okay, so a lot of times they'll have you simplify this. So by simplifying it, all we do is we multiply, just a little refresher. We multiply the square root of 39. It's called rationalizing. And the square root of 39 here. And when we do that, we end up with a little different looking problem. The square root of 39 times the square root of 39 gives us 39. And then 8 times the square root of 39 is that one. So the reason I show you that, guys, is because this here, oops, let's do a different color. This one here is equivalent to 8 over the square root of 39. They mean the same thing. So a lot of times your book will have this answer here. So your book will have this one here. All right. So on the next part, you'll be asked to answer a question. What would happen if the sine of A is equal to 5/8 instead of the sine of B? So answer that one for me. And that is our notes for today. Have a good day, guys.